Hello friends, welcome back. Today we will do a project to deploy a three-tier architecture in AWS using Terraform. So let's see what we'll do. Before that, let's see what is the three-tier architecture and what is it used for. So the three-tier architecture is the most popular implementation of a multi-tier architecture and consists of a single presentation tier, logical tier, and data tier. Okay, and it is a viable choice for software projects to be started quickly. So if you see the diagram here, we have the presentation tier, that is the client, and the logic tier, which is the server one. And this logical tier will contain the backend code like a PHP, Python, or Java, whatever you want to write the server side code. Okay, and the client, that HTML, CSS, and all these things will be the client side code. And the databases, we can use the database like MySQL, Oracle, or MongoDB, or whatever database you are comfortable with. You can use the database for this architecture. Okay, so what will create and what will install in this project. So these are the things, these are the resources need to be created or installed. So what we will create a custom VPC. So we are not going to use the default VPC. What we'll do, we'll create our own custom VPC using Terraform, and we'll use that one. We'll create two public subnets, one private subnet, two EC2 instances, one security group, elastic IP, NAT gateway, internet gateway, route table, application load balancer, Apache Webserver, MySQL DB. So until this application load balancer will use the Terraform to provision and create the resources in AWS. Once the server is created, everything is set up, we'll manually install the Apache Webserver, and for database we can install the MySQL. Okay, so this part I have knowingly kept it to manually install for this project. In our upcoming project, I can automate these things while creating the server. We can automate that stuff to be automatically installed for us. Okay, for the time I'll show you manually how to install these two, Apache Web Server and MySQL DB. So here is the complete picture of the architecture and what we are going to create in our AWS. So if you see the diagram here, we have our custom VPC of a CIDR range, CIDR block like 10.0.0.0/16. Okay, and we'll have two public subnets. One will be 10.0.1.0/24, and another one will be 10.0.2.0/24. Okay, these two will be the public subnet, and in this public subnet we will be creating the EC2 instances and security group. Okay, in one of them, and one of that one will keep the NAT gateway. Okay, so why we need this NAT gateway? We need the NAT gateway to provide the internet connections to the private subnet, because the private subnet we have kept it secure so that it will not have the direct internet access. Okay, so only the public subnet will be having the internet access, but the private subnet will not have internet access directly to the outside. Okay, so how we'll get the internet? Because we need to install softwares, we need to patch our databases, right, upgrade our databases. For that we need internet. For that we need the NAT gateway. To Through NAT gateway we'll get internet access, and we'll see how we can create the route table. Okay, and how we'll provision the internet gateway, provision the route table, and how we'll set off this, and how we'll route the traffic through the route table. Also we'll see, and at last we'll set off an application load balancer, and we'll see how the load balancing happens. Okay, this is the entire architecture, and this is the entire setup we are going to achieve in this project. Okay, so let's start. Let me explain you the code, whatever is being written for the resources we are going to create. Okay, let me open my VS Code. Okay, so I have already retained the codes for you, and these codes I'm going to explain you each and every resources, how it is being written and how you can write it. So if you see my screen here, I am using the VS Code editor. It's a very good editor. You can install it and you can use it for that. Okay, and it has the Terraform extensions and plugins there, so that it is whatever the code you are going to write in Terraform, it will help you to get the things automatically. Okay, now if you see here, I have used a resource block. It's called AWS underscore BPC. Okay, and I have given a name as main, and the CIDR block, this is the CIDR block argument you have to specify, and you know very well how to use the resources and where to follow. Okay, if you are not sure, you can go ahead and watch my previous videos on Terraform, but I'll just tell you, I'll give you a little hints on how to get it. Okay, just log into your just go to your registry.terraform.io, and if you go ahead here, you can see here all the in the AWS documentation page, you can find it all the informations over here. Okay, see, so I need the BPC resources of the BPC, right? So I have to go to the BPC sections here. Okay, go a little down here, and you can find here the BPC, the virtual private cloud. Just go ahead here and you can see the resource sections over here, and what I need to create a BPC, custom BPC, right? So what I have to do, so I have to just go for AWS BPC resource here, just go ahead, and here you can find how to use the BPC. Okay, simply you can just copy that and use in your block. So this is how you can use how the resources can be used in Terraform. Okay, and in the provider block also for AWS, you can know how to get the provider blocks. You can get these provider blocks from here. I'm not going to tell you much on this. Okay, so now let's go ahead and so what we need a custom BPC. Okay, then what we need subnets. Okay, two public subnet and one private subnet. So if I go ahead and for subnet, I'm going to use AWS underscore subnet resource block. If we go here and you can see here, see AWS subnet is here. Simply go ahead and get the informations what you need. So I have collected all. This is for basic usage, and for much for detailed usage, you can go ahead and can see how we can use this one. And here the argument sections, what are the arguments is mandatory or required, or whatever arguments are optional, you can find it everything over here. Okay, now so you just copy all this or put it in your code. So whatever I have did it here. Now let me explain whatever I have written to get this architecture done. Okay, so BPC ID. So BPC ID, this argument and the value whatever is captured is dynamically. So it is AWS underscore BPC dot main dot ID. So here the VPC whatever is getting created, the VPC name resource block is AWS underscore BPC dot main, and what is written dot ID. So the ID is the attribute where we can fetch the VPC ID. Okay, so here VPC ID and the CIDR block. So in the CIDR block, what is being retained here, I have created the variables. Okay, I have created the variables. If you go here the variable sections, okay, so just a second, if I go here the variables, I have declared these variables in this file called variables.tf. So you have to keep these variables in this variables.tf file. Okay, and here I have created one variable called CIDR, and here another variable is called AG, that is availability zone. Okay, and the type of variable is given as list. A default value I have given the CIDR range, like for two public subnet I have created as 10.0.10.0.1.0, another one is 10.0.2.0, and the availability zone is given as AP South 1A, AP South 1B, two availability zone being used. Now if I go here, so same thing I have been used here, CIDR block equal to var dot, I'm just calling the variable here var dot CIDR. Okay, and you know how to call these variables using var dot CIDR, and I'm using here is the count dot index. Okay, so what you'll do, and I have given the count equal to 2. So that means the count dot index is a special kind of variables and operators in Terraform. What it will do, it will get the variables. There are two variables in setup, right? Index, it will get a 0 and 1. So number of index are 2, and it's going to create 2 CIDR block, and it will be work in the loop. Like it will create 2 CIDR blocks, okay, and 2 subnets. And similarly, the first subnet will be created under the first availability zone and the index, and the second one will be created accordingly in the second availability zone. Now we are going to create 2 public subnet with this resource block. Okay, so next is so I don't need this part. Let me delete this. Okay. So what do we need? Next we have to create a private subnet. Same resource block I have used, like AWS underscore subnet, give a name as private, and I have used the VPC ID as that AWS underscore vpc.main.id, and CIDR block I have given 10.0.3.0. Okay, and here the availability zone is given as AP South 1B. Got it? Now what is given here actually, so here I'm just going into the data sections. I'm getting the AWS subnets, the values of the VPC ID. So here is given, so I'm getting the VPC ID and printing it over here. Okay, so now this is the subnet sections, and I'm getting all the details here. Okay, now what do we need? We have created 2 subnets. So next, go ahead and see what is the EC2 instances we have created. So let me close the variable file. Now if I go to the ec2.tf file, I have used here the source block as AWS underscore instance, given name as wave, and the AMI I have used this Amazon Linux 2 AMI instance type T2 micro. This is 3-tier available, and the key name to connect the server after provisioning. So the file name, the key file name I've given here, and you know where you'll have to get the key name and store it in your locally, right? So you can see here I have used subnet underscore ID, the subnet ID. So here is the subnet ID. I'm just getting it from the subnet is getting created here in the subnet.tf file, right? So what is that? AWS underscore subnet, and the subnet resource name is given as public. If you go here and see, it is named as public. Okay, so this is what I'm going to get it, and saying same thing here I have used is count.index.id. That means it will get the subnet ID of the first subnet created under this subnet.tf. Okay, count.index.id. Similarly, next one I have just added the VPC underscore security underscore group underscore IDs. So this argument here is being assigned the security group. Okay, so if you go to the security group sections here, say as the TF file, I'll just explain just after this file. Okay, so the security group attached here. Now you'll see here I have used another argument. It's called associate underscore public underscore IP address. That means whenever you see manually create any EC2 instances, you'll be selecting, right, whether the public IP will be created or not. You have to select, right? So this is what I have given. Yes, the associate public IP address equal to true. That means it will be associate a public IP whenever the server will be created. Simply count index I have given 2 because number of instances is going to create 2 only, right? 2 public instances will be created. And the tag I have given as web server. Okay, so the name of the server and tag is given as web server. And here you can see I have used the provisioner. Okay, file provisioner. I have used the file provisioner to copy the certificate files to the server newly created. I need this certificate file to demonstrate to connect to our private server from the public EC2 instances to the private EC2 instances. Okay, that's why I have used this provisioner block to copy the certificate file, so that whenever I just connect from the public instance to the private instance, I need this certificate file. Okay, to use this file provision, we have to use this connection block, because this connection block is required While copying this file, the connection is required. So here the connection sections, you can see type SSH and host, getting the public IP, user, EC2 user, and the private key. Okay, so it is pretty clear. You can see how it can be used. Now, after that, I have created the EC2 instances for the database. And you can see here, I have not specified any public associate public IP addresses. So it is by default, it is false. Remember, by default, it is false if you don't specify associate public underscore IP underscore address equal to 2. Okay, now all these things you understand how we can set up these VPC underscore security underscore group IDs and all. Okay, now let's go ahead and see what are the security groups we have created. So we have created here one security group that's called allow underscore TLS, and you can find this blocks how we can write it from the documentation page of terraform.io, right? And here I have created two ingress, like I have whitelisted two ports, one is 22, another one 18. Okay, and outbound is given it here. So here you can see the VPC ID, because I'm going to put the security group under the custom VPC which is created now. So this what is this? Another one is the for database. See, I have created two security groups. One is for web server, where we have access 22 and 80, and the second one also we have created the same another security group where the port number 22 is whitelisted, also the port number 3306, which is the default port of MySQL database, as we are going to install MySQL and use it for our applications. Okay, now it is pretty clear, and you can understand how the security group blocks being and resources being written. So the resource name is, remember, AWS underscore security underscore group. So what we got it now, we got our custom VPC. We saw two subnets, how to create subnet, EC2 instances, and security groups. Okay, let's see. So the NAT gateway, I'll just explain you a little that. Okay, before that, we need what we need. We have created all this. Now what we need the internet gateway and a route table. These two things are pending for the setup to start. Okay, now if I go ahead and check our code, so internet gateway, it is quite simple. You have to just use the AWS underscore internet underscore gateway. So this is GW is the gateway name. I have given underscore gateway, and this is the resource block name. VPC ID, under this VPC custom VPC, I'm going to create this internet gateway, and the tag I have given. The simple, only you have to specify the VPC ID where you have to create the internet gateway. That's all. Our internet gateway is created. The main point over here is that route table, because we have created our subnet, we have created our EC2 instances, right? But how the internet can be routed to our EC2 instances? Okay, so how we can connect to that and how it will be attached to the internet. So if you go to the route table, we have used here the AWS underscore route underscore table. So this is the AWS underscore route underscore table resource block where we are going to create our custom route table. Okay, remember, whenever you create the custom VPC, by default there will be a main route table created. Default route table will be there. Okay, so we are going to create our custom route table. Whatever is created by VPC, that will leave it. We'll create our own custom route table. Okay, so you have to use AWS underscore route underscore table. This is the resource block name, and which VPC I'm going to attach. So give the VPC ID name here, and you have to give the route section over here. Okay, in the route table, because I'm going to route this to our internet gateway. Our internet is created custom internet. Okay, and I'm going to route this to our internet gateway. Okay, so this is our custom internet gateway. Okay, as part of this VPC. So here the CIDR block, I have made it as public, and so that internet can be accessed publicly to this route table. Okay, now I've given a name as my route. This is the route table which is created, and so once the route table is created, we have to associate the subnets, right? We have to associate the subnets to the route table. So here is another resource block. It's called AWS route underscore table associations. So you can find over here. So if you go here, you can see here AWS underscore route underscore table. You can get all the informations from here. Also for the route table associations, also we can see it here, AWS underscore route underscore table associations. So here is the example how we will associate the internet gateway to the route table. Okay, simply just copy it here. Okay, same things. If you can see here, I have just created AWS underscore route underscore table underscore association a. I have given name as a. So here the subnet ID. Okay, so you can see here we have created two subnets, two public subnets. Okay, so I'm going to give internet connections, internet to both of the public subnets. Okay, so that's why I've used AWS underscore subnet dot public and count dot index dot id. So it will get the subnet ID of both of the public subnet and the route table ID. So this is the route table ID. What is this? AWS underscore route underscore table dot rtb. You can see it here, dot rtb and dot id. So whatever is created, whatever the route table will be created, the route table ID will be added here, so that I'm going to assign these subnets to this route table. Understood, right? Now, so this is all about the routing to the internet gateway. Okay, now this NAT gateway things I will explain little later, in maybe in our next video. I'll just tell you how we can set up the NAT gateways and all. Okay, for the time being, leave it. Now, so everything we have created. Okay, now you understood quite well, right, how the codes can be retained in Terraform and how it can be used. Okay, now let's go ahead and execute the Terraform commands. Okay, let me go to my terminal. Okay, I have kept all the Terraform files which we need to create in this directory. Okay, in this folder. So as you know, if you are going to execute first time, and first you have to initialize the Terraform to use that respective provider. Okay, so you have to use Terraform init. Now what it'll do, it will just download and install that plugins or providers for us. Now the Terraform has successfully initialized. Whatever, let's do and check and do the Terraform plan to check whether everything seems fine. Terraform plan. If there is no error, nothing, so everything so it looks everything good. Okay, so we can go ahead and check. All looks good. So if you see here, what it tells, it is going to add 13 resources. Okay, it is going to add 13 resources and 0 to change, 0 to destroy. So if you go up, you can find all the details like the instances and everything, the image ID, the T2 micro, like the instance type, key name, everything are there. Similarly, the internet gateway. Okay, all these things will be there. Now let's go ahead and do Terraform apply. Okay, let me clear the screen. Use Terraform apply. Hit enter. Yes, let's give a value as S. So what it does, it's just creating a BPC, AWS subnets, okay, security groups, and internet gateways and route tables, okay, or on instances. All these things are creating one after another. Just wait. Here it is. So now it has created 13 resources. 13 added, 0 changed, and 0 destroyed. Okay, so everything has now created as per the plan. So let's go ahead and check our AWS console. Just log into the AWS console where you can see the resources have been created. Okay, Now if I go ahead and click this instances, so see, all these instances have been created. So we had two web servers, right? We have two web servers which are creating, and you can see here it is just initializing, right? It's just initializing, and we have one DB server that's also getting initialized. So these three servers being created as part of the Terraform. Okay, just wait for a few seconds. Let's all this status get passed, the checks get passed, and then we can go ahead and try to log in. Okay, so we have created our internet gateway, and we have routed the internet gateway through the public subnet. That means we should able to connect the public subnets. Okay, now fine. So our EC2 instances is created. Now let's go ahead and check the VPC, the custom VPC we have created, right? So if we go ahead and check the VPC, so here you can see in the VPC dashboard we have these two VPCs created, right? Just click on that and you will find the VPC which is custom VPC created, and this is the default VPC. When the account was created, it is the default VPC, and this is the custom VPC which we just created. Okay, and if I go to the subnets, I'll find like three subnets we had created, right? The public subnet, here the publishing, you can see that the VPC, the custom VPC which is attached. Remember the default VPC which will be as part of your account creation, that will have also three subnets, as the Mumbai region is having three availability zone. Okay, so now we have created also three subnets, two public subnet and one is the private subnet with the different CIDR range, cylinder block. Okay, and similarly we have this route table also. You can see this is the custom route table which we created, named as my route. If I go to this route table, we'll see that this internet, the route has been given to the internet. If you go ahead and see the subnet associations, yes, we have these two subnets associated to the internet. Okay, now we can see how we can do the associations, right? Fine. So let's go ahead and check whether we can able to access the servers or not through the internet. Okay, if I go to the EC2 instances, get the public IP, go to EC2 instances, and here you can see if we select the instance, and you'll see there will be a public IP associated here, right? If I open this DB server, right, see there is no public IP associated, because while creating the instances we have not specified the public IP argument to create the or associate the public IP, right? Now let's go ahead and connect to any one of the server and see whether we are able to connect or not, or whether the internet is going through or passing through or not the traffic. Let's go ahead, clear the screen. Okay, so we have the certificate key available here in this directory. So let me use ssh-i certificate, and good, we are able to connect now. See, that means we have the internet connectivity and we can able to connect using this certificate. We can able to connect it. That means we have the required firewall access and everything is in place, so that we are able to connect and see whether we have the internet connections to that or not. Okay, now if I go ahead and do install the web server, okay, if I do yum install httpd yes, so it is installing. That means we have internet connections to this server. Okay, so the public server, one server, we can see we have access, we can able to connect the server. So let's see, let's go ahead and see the second server whether we have that internet access or not. Okay, let me exit out from this server. If I go ahead and use the same command, instead of the public IP, I'll just get the public IP of the another server. Okay, let's go ahead, get it, enter, yes, got it. So let's see, sudo yum, same command we are going to use it. Okay, httpd Yes, hit enter. So we can see here we can able to access the internet and we can able to install the software. Now you can see how the entire architecture we have set up using the Terraform. So route table, internet connectivity, internet gateway, everything has been set up successfully. We can able to access the server. However, if you go ahead and access the DB server, let's see what is happening when we access the DB server. So how we'll access the DB server first of all? Because we do not have the public IP. So how we can access? We can access from one of the public instances, that is one of the web server. So let me copy this private IP of the DB server. Okay, so from these public instances, I am into one of the public instance, right? We have this key available here. Okay, and this key you can see is actually open, like it is actually security conscious. So what you have to do, we have to change the permissions. Let me change it to 400. Keep the certificate name and changed. Now if I use ssh-i use the certificate to connect the private instance, okay, give the private IP here. Okay, good. Now what we can do, from the public instances we can able to and successfully can connect to the private instance, our DB server. From our web server to DB server we can able to connect. But suppose you want to install something in the DB server, or you want to upgrade your software, how you'll do it? Because we'll not have internet activity now. Let's see whether we have internet connections or not. So simply if you do sudo install MySQL here, yes, sorry, there is something wrong. So I forgot to use the package manager here. Sudo yum install. Okay, sudo yum install MySQL -y. So what we'll do, you can see here it is being waiting for the internet connections. So it will wait for some time and then it will be terminated with timed out error. Okay, then here what we can see here, we have internet connections to the public subnets. However, we do not have internet connections to our private subnet. Okay, so in our next tutorial, in our next video, we'll see how we can set off the NAT gateway, how we can create our NAT gateway in Terraform, and how we'll route the internet so that our private subnet, okay, so that our private subnet can able to connect, and the internet access will be there, and we can, through public subnet, we can able to connect to the private and then install the softwares. Okay, so that's all for today's video, guys. You can see here also we have received the timeout error. Okay, see, connection timed out. Okay, now you understood. So in our next video, I'm just going to show you the setup of NAT gateway. I hope you understood clearly, and if you have any doubt or anything, please do comment me in the comment section below. If you have not subscribed my channel yet, please do subscribe so that you'll get notified whenever I add new videos related to the automations. Thank you, guys.